In second complex, Fe present in +2 oxidation state. हे तुम्हाला कॅल्क्युलेट करायची गरज नाही, हे जस्ट रफ कॅल्क्युलेट करून घ्यायचं आहे. तुम्हाला माहिती असावं की Fe कोणत्या ऑक्सिडेशन स्टेटमध्ये आहे, आणि डायरेक्टली माहिती असेल तर यू कॅन डायरेक्टली कन्सिडर. ओके, so what is the first point? Number of electrons of Fe atom. किती आहेत? atomic number Fe चा 26 आहे. ओके, सेकंड पॉइंट असतो the number of electron lost by Fe. How many electrons lost? 2 electrons lost, because oxidation state is +2. So 2 electrons are lost. Third point is number of electron gain. Number of electron gain by Fe from ligand. You can mention the ligand or not. Okay, so how many ligands? 6 ligand. So 6 into 2 is equal to 12. So first of all, we know all the values, so we calculate ENA is OB or not. So number of electrons of metal 26 minus number of electrons are lost 2 plus number of electrons are gained is equal to, so 26 minus 2, 24 plus 12 is equal to 36, is equal to 36. That means here is the krypton, here is the krypton. So given complex is obeyed EAN rule, obeyed EAN rule. Come on the next. Nickel, there is no oxidation state and CO is neutral, that means nickel present in zero oxidation state. So Ni present in zero oxidation state. So we directly calculate number of electrons of nickel Ni is equal to 28 is the atomic number of nickel. Second, number of electrons lost by Ni is equal to 0. There is no oxidation state, there is no electron loss during formation of complex. Third, number of electron gain from ligand. Here, how many ligands? 4 ligands. So 4 into 2 is equal to 8. 4 into 2 is equal to 8. So how to calculate EAN? Number of electrons of metal is 28. Number of electrons lost 0 plus number of electrons get 8. So 28 plus minus 0 is equal to 28 plus 8 is equal to 36. It is equal to the krypton. Again the complex obey EAN. Complex obey EAN. Last one. In given complex, platinum present in +4 oxidation state. Because of NH3 is neutral, so charge of the complex is equal to oxidation state of the metal. So here platinum is +4. Platinum is +4. So first point is number of electron of platinum. Atomic number is 78. Atomic number का है 78 है. Okay. Second point असेल number of electrons lost by platinum. How many? 4 electrons are lost because oxidation state is 4. Third point is number of electrons gain from ligands. How many ligands? 6 into 2 is equal to 12. 6 into 2 is equal to 12. So how to calculate EAN? EAN is equal to number of electrons of metal 78 minus number of electrons lost, 4 electrons are lost, plus 12 electrons are gained. So 78 minus 4 is equal to 74 plus 12 is equal to 86 is equal to 86 is the atomic number of radon, is the inert gas. That means again complex obey the EAN rule. obeyed EAN rule. So here all the four complexes obeying the ANA rule, because all the complexes, the sum of the number of electrons of metal plus electrons of lost, then number of electrons are gained is equal to the inert gas configuration. That means all the complexes obeying the ANA rule. We are going to discuss some complexes which are not obey. In exercise, the number of complexes is given to you. You can try all the complexes, solve as a assignment. Next complex is CrNH363+. So in given complexes, neutral molecule is present, complex having +3 charge. So the complex charge is equal to charge of the metal. Means here Cr is +3. Cr is +3, that means 3 electrons are lost. So according to rule, the first point is number of electrons of Cr. What is the atomic number of Cr? 24. 24. Second point, number of electrons lost by Cr, chromium. What is oxidation state? 3 oxidation state, means 3 electrons are lost. Third point, number of electrons gained from ligand. Here 6 into 2 is equal to 12. So according to rule, EAN is equal to 24 minus 3 plus 12. So 24 minus 3 is the 21 plus 12 is equal to 33, and this is not equal to the 36, because for first transition series, the first noble gas is chromium, for second is xenon, and for third is the radon. So chromium belongs from the first transition series, 3D series, okay. And in first transition series, the last element, the inert gas element is krypton. So it is krypton 36, but it is the total is 33. That means it is not equal to the 36. Means you can mention here not obeyed EAN. Not obeyed EAN. Okay. Another example is given to you. FeCN6 3+, FeCN6, 3 minus. So again, first find the oxidation state. Here Fe present in +3 oxidation state. How it? You can calculate x plus minus is equal to -3. That means x is equal to +3. Okay, हे तुम्हाला calculate करता आली पाहिजे. So number of electrons of Fe, atomic number 26. Second, number of electron lost by Fe. किती इलेक्ट्रॉन लॉस केले? 3 इलेक्ट्रॉन लॉस केले, कारण की ऑक्सिडेशन नंबर आहे 3. थर्ड पॉइंट इज number of electrons gain from ligand is 6 into 2 is equal to 12. So here EAN is equal to 26 minus 3 plus 12 is equal to 26 minus 3, 23 plus 12 is equal to 35. And again it is not equal to 36. So total is not equal to 36. That means again you can mention here not obeyed EAN rule. Not obeyed EAN rule. So this way you can calculate whether the complex is obeyed or not obeyed the ANA rule. So solve all the questions which was given in exercise as an assignment, and then if you have any difficulty you can put your questions with the complexes which you are not understand. So the point is next the merits and demerits. So every theory has some advantages, some disadvantages. Okay. So according to this theory has some advantages. So the first advantage is the theory helps us to predict the coordination number, means how many maximum ligands are attached to the central atom, we can predict it. So the coordination number is predicted by the sidwick theory. Second, it explains the stability of complexes. That means those complexes which obey the ENA rule considered as a stable, most stable form. So according to this theory, there are two advantages. We can predict the coordination number, means how many or certain number of ligands are attached to the central atom or ion, we can predict it. Secondly, we can predict the stability of complexes. Those complexes which are obey the ENA rule are stable, and those are not obey, we can consider as a less stable, not unstable. These are the merits, these are the advantages of sidwick theory. But there are some merits, demerits, means some limitations. ENA rule can applicable only for the some complexes, not for the all kind of complexes. Means every complexes we cannot be explained by sidwick model, because of some complexes which are exist in a more stable form, but the complex is not obeying the ENA rule. म्हणजे काही कॉम्प्लेक्स असे आहेत की जे ENA रूल ओबे करत नाही आहेत, पण तरी सुद्धा ते स्टेबल आहेत. कारण की स्टॅबिलिटी कॉम्प्लेक्ससाठी नंबर ऑफ फॅक्टर्स रिस्पॉन्सिबल असतात. त्याच्यातला हा एक कन्सिडरेशन होतं की सिडविक मॉडेल म्हणजे ENA रूलने आपण एक जस्टिफिकेशन करू शकत होतो की कॉम्प्लेक्स हे स्टेबल आहे, कारण की ते ओबे करत आहे, की इनर गॅस कन्फिगरेशन अचीव करते म्हणजे स्टॅबिलिटी अचीव करते, म्हणून त्याला स्टेबल म्हटलं जात होतं. पण नंबर ऑफ कॉम्प्लेक्स असे ज्यांच्यामध्ये ENA रूल ओबे होत नाही, पण तरी सुद्धा ते स्टेबल आहेत. हा या थेरीचा लिमिटेशन्स आहे. सो व्हाय सच कॉम्प्लेक्सेस आर stable, those are not obeying the rule, cannot explain by this theory. Second, the ligands which are donate the electron pair to the metal. ऑलरेडी म्हटलं की लिगँड हे इलेक्ट्रॉन डोनेट करतात मेटलला. जर त्यांनी मेटलला इलेक्ट्रॉन्स डोनेशन केलं तर बघा की नंबर ऑफ इथं 12 इलेक्ट्रॉन्स डोनेट केले, म्हणजे इलेक्ट्रॉन हा निगेटिव्हली चार्ज आहे आणि तो डोनेट कोणाला होतोय, मेटलला. सो मेटल ॲक्सेप्ट द इलेक्ट्रॉन्स, ॲक्सेप्ट द निगेटिव्ह चार्ज ओव्हर इन इट, on it, then the metal appear some negative charge on it. But we say metal always positive, metal is in a oxidation state, plus oxidation state. That means how it possible, metal in some kind, in some part metal is positive. When accept the electrons, negative charge, after accepting an electron, how metal become positive at every time? Because after once accept the electrons, it is possible metal be negatively charged because negative electrons are accepted. This thing is cannot be explained by the sidwick model. And sidwick model does not predict the geometries, about the geometry. What happen about the geometry? If complex is formed, but what is the geometry? Which geometry is possible cannot be mentioned in sidwick model. So sidwick model is very limited. It is just related to the ENA rule only introduced by the sidwick. But other factors related to the coordination complexes cannot be explained. So that's why this theory has some limitations, number of limitations. Only one or two merits or advantages of this theory, but there are a lot of limitation. That's why the theory is not much useful. But at that time when the theory was introduced, that time it is helpful to predict the something about the coordination complexes. But now it is a advanced chemistry. We can predict the coordination complexes, their parameters, their number of things is in different way. Means different techniques are available, different theories are available or methods are available to predict the or information about the coordination complexes. But when the theory was introduced, that time there is limited concepts are available, limited theories are available. That's why that time the theory is useful. But now the theory is not much useful because MOT, VBT, CFT, there is advanced theory which are used to predict the coordination complexes, there to understand their chemistry of coordination complexes. So today we stop here. We're going to discuss the another concept in next lecture. Maybe in next lecture we're going to solve or we're going to discuss different topics. So we stop here.